All right, here's the last kind of calculation that you need to do for this module. What is the E under the following conditions? Please note that we have lost the standard symbol, so this is no longer under standard conditions. And please note that some concentrations are given, and you may recall from the thermodynamics chapter that standard conditions for thermodynamics for solutions is 1 molarity. These are not 1 molarity. We are now under non-standard conditions. So since we're under non-standard conditions, we need an equation for non-standard conditions, and this is it. It's also known as the Nernst equation. Now you will notice it looks an awful lot like some of those up above. It comes from those up above. You can see its derivation in the textbook, or holler at me if you want more help with that. But I do need R, I do need F, I do need the T, and I do need the N, the number of moles transferred. So we've got some similar calculations. This is just another calculation. Here's a formula to have on your formula sheet. Again, once you identify, I've got a non-standard, I've got some solution concentrations. That's related to the Q. Remember that from the equilibrium chapter. Q is calculated just like K. It's products raised to the coefficients divided by reactants raised to their stoichiometric coefficients, but I don't include solids, I don't include liquids. So Q for this equation, here's my reaction. For this chemical reaction, Q will be the concentration of cadmium 2+ cubed. I will not stick the aluminum in there, it's solid, because aluminum is a solid, divided by the aluminum plus 3 squared. I will not stick the cadmium in there, it's solid. And the questions on your question practice, it does point out the states of that. When I recopy it onto my sheet, I get a little lazy. So there is my equation. There is how I calculate the Q. All I have left to do is plug and chug. Now you will notice it did not give me the E0, but I do need the E0 in order to solve for this. How do I get the E0? I got to split it up into the half reactions. Let me watch my balancing and look up those values. I'm not going to scroll through it with you because that's going, you scroll through your E0 tables, half reaction tables, and I found aluminum plus 3 goes to aluminum. It needs 3 electrons on this side, but notice that there are 2 of these guys. That means I need 6 electrons on this side to balance it. You can confirm that. And the E0, the standard cell potential for that half reaction, it's written in the table as Al plus 3 electrons going to Al. That is negative 1.662 volts. I do not multiply that by 2. That is the cell potential, the standard cell potential for that half reaction. I do not multiply it by 2. Now, I do need to know that there are 6 electrons being transferred. It's looking like N equals 6. I'll confirm that with the other half reaction. And by the way, in case I didn't say it, I don't know if I did, we're looking these up in the table because I need to calculate E0 to be able to plug into this equation to solve for E. So that's why we're looking it up. It's also helping us get the N value, the number of electrons transferred, as I pay attention to the balancing. The other half reaction is 3 cadmium solid going to 3 cadmium plus 2. And if I look up cadmium, it is backwards. It is listed as cadmium plus 2 electrons going to cadmium solid, but again, it's multiplied by 3, which means there are 6 electrons needed to balance that. You can confirm that, you can double check that, but you will notice we have the same number of electrons on both half reactions. We have to. If you don't have the same number of electrons on both half reactions, you've made a mistake somewhere. I did have to flip this reaction, so I will change the sign. So it is positive 0.4030 volts as I take it out of the table. The table lists it negative. I grab the positive because I flipped the reaction. I did not multiply it by 3 because you don't. That is the cell potential. So the E0 For this reaction, I'm calculating the E naught for that reaction is by looking up the half reactions in the standard cell potential tables and adding them together. Double check my math. Okay. I get negative 1.259. I am not rounding this because this is not my final answer. This is not my final answer. So don't round it yet. All right, now I'm going to plug into the equation. So here's my equation again. That's what I'm plugging into. So E equals E naught, which is negative 1.259 volts, minus RT over NF log Q. So 8.314. Be careful plugging this in. 298 for temperature. My N is 6. F is 96,500. Notice I've rounded that a little bit from the book. That should work. Times the natural log of Q. Remember, this was my Q, so let's plug that into Q. I've got 0.030 cubed on top, 0.020 squared on bottom. Trickiest part of this is getting it plugged into your calculator. Use lots of parentheses. If you tell your calculator is stupid, it does exactly what you tell it to. If you tell your calculator to do the wrong thing, it will do the wrong thing and give you the wrong answer. So take a minute, plug that into your calculator. You could do it in pieces if you want to, but do not round in the middle. Do not round in the middle. I am getting negative 1.24746. The instructions will be given. Negative 1.247 volts is my final answer. Typically, if you look at what the E naught was, remember our standard E naught was negative 1.259. Typically, they're not that much different unless the solutions are just way out there. So we are kind of expecting something in a similar, there are circumstances where it can be very different than the standard cell potential. But I think if you get something close, you can probably figure out you've probably done the calculation right. This is one of the trickiest calculations, and it's the math. It's not the chemistry, it's the math. It's a plug and chug problem. Practice it on your calculator until you come up with the same answer. You can keep repeating these problems over and over again on the homework to make sure as you plug in different values, you're still getting the correct answer.